I'll give you guys a few moments to answer that.
So almost all the votes are in, and it appears that about 2/3 of the attendees today are primarily managerial in their role, but I'm sure that they have some technical understanding as well, since they're probably IT managers. And then a third of us or so are mostly technical. Very
okay.
Good.
And our next question is, how deeply has your company investigated virtualization technology? Not at all. We've tested, played with it a little. We've piloted it, or we haven't implemented for production use. Okay, Kevin, it looks like about 86% of the votes are in.
Very good. So about half haven't really played with virtualization technology in their company yet, but a couple people seem to have varying degrees. So we'll make sure that we cover some basics just to get everyone up to speed before we really dive into some things. And the last poll?
And our last question today is, what is the primary business problem you hope virtualization will solve? IT expenses too high, availability too low to applications and data, and insufficient flexibility or agility. All right, it looks like most of the votes are in, Kevin.
Yeah. So I guess I'm not surprised that many people are thinking about money, and maybe virtualization can save money, so we'll make sure we spend some time on that. But it also has other benefits that we'll speak about for businesses, so we'll cover all of it as well. I think we're all set with the polling, so thank you for your response to that. And I'm just going to switch things here so you guys can see my presentation screen. And if, Linda, you could just confirm for me that you see the welcome slide that I have.
Yes, absolutely. It's up.
Super. So I'm going to split the time that we have together today, which will be roughly in the format of 30, 35, maybe 40 minutes if I talk slowly, covering all of the material. But I'm going to break it down into these basic areas. First, we're going to cover some definitions of virtualization so that if there's any new lingo, I don't leave anyone behind. And after that, we'll get right into talking about the business benefits of doing virtualization in IT of different types. And that relates directly to the business impact that we're hoping to uncover for you today. Then we'll move on to, honestly, that there could be some drawbacks for virtualization. So I want to be honest about not only the pros, but also perhaps some cons that you need to be aware of. And then we'll talk about various resources and costs of doing virtualization of different types, so that you have an idea. And then we'll wrap up with our Q&A session at the end, like Linda spoke about. So getting on to the first part, which is definitions. Just want to set the baseline here. We've all heard of virtual reality, I would think, because we see it in movies. We see gadgets like people donning goggles, and they see a different world in front of their eyes than what they're really seeing. And perhaps some of the older people in the audience, like myself, remember the jingle, "Ain't nothing like the real thing, baby." Well, that used to be true in IT, but now there is something perhaps better than the real thing, and that would be the virtual thing. So we'll talk about that. Virtualization is really separating one part of IT from the actual underlying layers of technology. One example that you can think of this would be the movie The Matrix, which is one of my favorites. In the beginning of that movie, you might recall that people thought that they were living in the real world, but actually it was a computer representation being sent into their heads that they're actually being controlled and were acting like batteries for the robot world that controlled them. But that movie kind of demonstrates how they thought they were seeing the real world, interacting with it, but they really weren't. And in IT, that is true as well when we talk about virtualization. I'll get into some examples that'll make this come clear, but I think the general idea is that we're faking something out in IT. Maybe it's an application that thinks that it has a lot of memory to use when the machine really doesn't have that much memory. So it's just a little bit of abstraction in between layers of IT that really give a lot of advantage and flexibility. Well, in IT, virtualization can be done in lots of ways. So we're going to speak about some of those. I bet you if you thought about it, you'd realize that you're actually doing virtualization in your computer environment now. Because one of the most popular and long-standing ways was to do virtual memory. This is where an operating system handles things behind the scenes for applications and makes them think that they have more memory available to them than what is physically in that workstation or server. And this screenshot that I have here shows the virtual memory setting box that may look familiar for Windows users. That is a type of virtualization. We just happen to be applying virtualization techniques to how we manage and present memory. Another type of virtualization I bet that you've got involved in your IT world is regarding storage, where the hard drives that you have are not really the hard drives that the operating sees. An example of this would be when we take multiple hard drives and we use technology like RAID, and we combine those hard drives together and make them look like one or more larger hard drives than what they physically are. Again, that is really virtualization. It's just applied to the storage layer. There are a few other techniques that we can use to virtualize storage, including iSCSI, which is a way of accessing hard drives across a network using this iSCSI protocol. Yet to the operating system, it appears that those drives are locally attached, like in the server. So we can see some of the benefits there. And then there's some other technologies that take lots of storage that might be scattered across, locally attached or across the network, and again make them like one large pool of local disk. So again, you have virtualization in memory and storage probably in your environment. Another type of virtualization is network virtualization, and if you've ever heard the term VLAN, which means virtual LAN, or have trunks or ISLs or link aggregation or any other term that really means the same thing in your environment, then really what you're doing is virtualizing your network layer, in that you've got separate parts of it that really can't see each other. They think that they have their own network, but they're really sharing, and that level of abstraction, those VLANs, again, is a type of virtualization. The last common one is virtualization for applications. We've been doing this for quite a long time when we talk about remote desktop, or now called remote app in Windows. Or for Citrix users, it used to be called WinFrame, then they changed the name to MetaFrame and Presentation Server, and now it's called XenApp. That again virtualizes applications so that it looks like it's running on our machine when it's really not. It's running across the network and being presented to us. But today's presentation primarily deals with the last two types of virtualization that I'll speak about, being server and desktop. So let's set some baseline knowledge here about server virtualization. What is it and what does it look like? Well, the traditional way of doing servers is what I have on the screen here, where the blue boxes represent physical Dell, HP, IBM servers, and each one of those has its own operating system like Windows or Linux or NetWare loaded on it, and then some set of applications which store data. Unfortunately, we pay as customers 100% for that server that we've purchased, but in reality, we're not using 100% of the server 100% of the time. As an example, across the IT industry, servers are only really using 5 to 10% of their processor on average across the day. So we're spending for resource that we're not using very efficiently. So this is what server virtualization does, is we usually bring in, oops, I went the wrong way, a new physical server. We install some software which makes that hardware separate from the operating systems, and then we can remove the physical servers out of play to either be used as spares, reused for other purposes, sell it and get some money back, or donate it and get a tax credit. And then those applications and operating systems that we're running on their own physical servers still think that they are, but they've been modified very slightly in terms of some drivers, and they think that they're talking to their own server, but they're really sharing that one physical server. And in that case, where each server had been using maybe 5 to 10% of the CPU, they are now sharing that CPU, so the physical CPUs are really being used now maybe 20 to 40%, or the aggregate of what those 4 separate boxes had been. And if you have a server powerful enough in the center there, then there's no limit really to the number of what we call virtual machines, which are those green operating system and application boxes. I've just demonstrated with 4, but it could and is commonly 10, 15, or more virtual servers running on one physical box. So we not only overcommit and share the CPU, but we share the RAM as well. And there's some tricks that that virtual server software plays, so that, as an example, if the same program or operating system file on server number 1 is loaded into memory, and server number 2 running maybe the same application or operating system comes along and loads the same one, they actually share that piece of memory so that only one copy of the program is in the physical server. Like, the 2 servers don't realize, they don't fight, they don't have to have anything special done to them to share, but that's that virtual layer of software playing some magic there. And they also share hard drive space, because often with physical separate servers, we might have some extra resources like some free disk space on server number 1, and server number 2 really needs it, but it can't because it's locked inside that server number 1 box. When you virtualize servers, then you're sharing your CPU, your RAM, your I/O, as well as the disk, and you can shift free disk space around, take it from the servers which have maybe too much, and give it to the servers which need more. So again, that's another way of using more of the resources that you've already paid for. There are also some other neat functions that can be done when you have virtual server software. And as an example, if you wanted to test what an upgrade of an application would do on a server, you can take a snapshot of that server, which is a virtual server software function, modify that copy by installing the test application you wanted to upgrade, seeing how it goes, and if it doesn't work out, then you just click a button and you delete that extra copy. But if it does work out, then you can get rid of the original and swap this one in its place. So because you can bring servers up and down, create new ones and delete them very quickly, it's not dependent upon a physical server box being available, you have a lot of flexibility to customize things and try things. Doing this sort of virtualization also makes those operating systems independent of the hardware, so that hardware upgrades can be done much easier. I can swap out that blue physical server in the middle there that's running all of these with a new piece of hardware, or add RAM or hard drive space, and the applications and operating systems in the green boxes on top would not know that something has changed, because it's virtualized, it's removed from what the physical hardware really is. The network support company has proved out virtual server technology and to the point, and seen its value for so many of our clients, that our standard recommendation is that we would use server virtualization for nearly all environments that have more than one server. Even if it's just 2 servers that need to be created, we would usually buy one physical server box, put on this layer of virtual server software, and run 2 instances of the Windows operating system usually on that server. And then if a third server needs to be created, you don't buy any more hardware. If you have enough resource left over, you simply install the operating system and keep on using it. Well, I'm going to switch gears just a little bit here and describe how virtualization works with desktops, which is a similar concept in that we're centralizing resources, but there are a couple things that we do differently when we virtualize desktops. When I mean virtualized desktops, what I mean is that we're splitting where the screen and the keyboard and the mouse is, which is the user's interface, and where the PC that does all the running of the programs actually lives. When we virtualize desktops, that operating system and applications and all the hardware necessary for running it are removed from the user's desk, leaving them just the keyboard, the mouse, and the monitor. And we instead run those things as virtual machines on that centralized hardware that can be the same hardware and software that does the virtualization that we use for servers. So you can virtualize servers and desktops together on the same physical server box. Let me show that in a different way. Similar screen to when we virtualized servers. We would again bring in the physical server, add that virtual layer of software, and in this case we remove the physical PCs instead of the physical servers, leaving the Windows 7, Windows Vista, XP running nearly unmodified, but thinking that they had their own PC hardware behind it. Well, here's what's different when you virtualize desktops is that we need to add in a new piece of software that manages those virtual desktops. And this allows some functionality that I'll speak about in just a minute. But from the end user's perspective, they would then have their keyboard, mouse, and video connected to a little box called a thin client. And when they turn on that box, it would connect to this central desktop management software. And it would authenticate, okay, who are you, and what desktops do you have privilege to access? Since now they're all together in the same place, we just need a way to distinguish which one they should get to. Well, based upon the credentials of Kevin Rhodes, as an example, he would be redirected and reconnected automatically to a particular virtualized desktop. Once connected, it looks and acts the same. I'm still running Windows 7. I'm still running the Office applications. I can still print. I can still plug in PDAs to sync. Nothing really is different except the hardware at my desk looks a little smaller. And maybe, hopefully, it's faster if that physical server in the center there is stronger than what my old desktop PC used to be. One advantage of running this way is that those thin clients that I spoke of at the top that go at the user's desk can either be an old PC that was too old to run any other function, but since it's really just doing display for us, can be a very low-powered PC. Or it can be replaced with a thin client device, which are cheaper to purchase than PCs, usually in the range of $200 up to $500, depending upon some features and functions that you might need. And another advantage is that thin clients use only 10% or so of the electrical power that a PC uses. And if you have a large volume of PCs that are on nearly continuously throughout the day, we saw one client that was spending about $50,000 a year on electricity that would be saved by switching to thin clients and just the electricity savings alone. These thin client boxes also don't have hard drives that spin and are more likely to break. They don't have really any real operating system that needs to be managed. You don't put antivirus on it. You don't have to license Windows for it. A lot of advantages. They're just simple, cheap, almost like dumb terminals used to be. But they do connect us to that virtual desktop to give us all the functionality that we want. To expand just a little bit more on virtual desktops, there's a few extra features that I mentioned the virtual server software could to do when we virtualize desktops specifically. And there's 3 ways that we can virtualize desktops. One is an individual desktop. An individual person has an individual desktop, and it is theirs just like their PC was under their desk. If they install an application, it's theirs. If they customize a setting, it's theirs. If they break it, it's theirs. That can be done when that desktop is virtualized, but there are two other ways of doing desktop virtualization as well, and they're called pools. A desktop pool can either be persistent or non-persistent. A desktop pool means that you have one master copy or implementation of a desktop image that might have Windows 7 and Office installed just the way that you want, and all of the line of business applications that it takes to run your business. And you save that as kind of like a gold copy. And then when people connect to their virtual desktop, if they haven't done so before, they get a copy of that master template, and it becomes theirs to customize in any way they want, but at least they start off with all the way the applications and settings the way that you as an administrator would want. A non-persistent pool is a little bit different in that a persistent desktop pool, a user connects to a new copy of a desktop when they connect the first time, but then it's theirs forever, just like that individual desktop was. Whereas a non-persistent desktop pool PC, they get a new copy every time that they connect, so it's always refreshed back to the way that it should be. So they can't customize it, can't break it, can't install applications they shouldn't be. And we see this most often applied to, say, call center environments, agents that do the same sort of work over and over and really don't have need for customizing their PC. Well, I've spoken about the five, I think it was, different types of virtualization: memory, application, etc. But all of them share common benefits of why a customer would want to do virtualization. And they break into three categories, and here's where the business aspect really comes out. A lot of people asked about how virtualization might lower their cost of doing IT because their IT expenses are too high. So let's speak about costs first. Virtualization, generally speaking, has a very, very good chance and history of lowering IT capital and operating costs, and it does this in a few different ways. One is you're generally reducing the physical infrastructure that you need in your environment when you virtualize, because you're sharing resources and using more of them rather than letting things sit idle for most of the time. So we're buying less servers, fewer desktops. We don't need as many network ports to connect all those things together if we're running less desktops and servers. If you have less equipment running in your server room, you don't need as much cooling, physical space, electrical power supply, etc. And all of these things add up to save you money. As an example, with server hardware, if you had 10 servers that were underutilized and only using 5 or 10% of each one of those, if you were instead to buy a server that is about the same size as those and virtualize everything onto that one, you'd be spending roughly 1/10 of the money that you spent on servers the old way when you now virtualize and use more of that one box. I spoke about a few ways that the virtualization software is lending to the efficiency, and so that you're actually sharing memory, sharing hard drive space, so what you buy for virtualization actually is extended beyond the normal life because of these extra tricks that we do. You can also run different operating systems on the same virtual server hardware simultaneously. There's no reason you can't run your Windows 2008 box, your Windows 2003, maybe even DOS or Windows 3.1 if you have an old application. You can run these all on the same piece of hardware where before you had to have your own PC running Windows 2008 or server running Windows 2003, etc. Now they all share, and you can even share with non-Windows or non-Microsoft applications. You can run Linux and Unix on the same piece of hardware at the same time as Windows or NetWare. The list of operating systems and the particular versions that you can run is 470 operating systems and individual versions, at least for the VMware product, which I'm going to speak about a little bit later on. If you have less hardware in your environment, then there's less to break and maintain. Desktops being replaced by thin clients which do nothing but boot up and connect, no spinning hard drives. Well, fewer hard drives to break, as an example. The second category of benefit is regarding the increased availability of applications. Really, IT is all about making information and the applications which process that information useful to users. And if your server is down or their PC is broken and they can't connect to their applications, well, that means usually lost business, lost productivity. So virtualization technology can be employed to increase the availability of those applications to the end users. There's a lot of features that can be used to make the servers run longer without issues, or redundancy between virtual servers so that if one fails, everything automatically keeps on running on the other server without interruption to your users. That's powerful stuff. And lastly, in this category, you can eliminate some of the planned downtimes that you might have for servers, because if you have two redundant virtual servers, you can move all of your virtual things over to the second server, and that does not disrupt users. Upgrade that first piece of hardware or fix an issue, swap out the controller that failed, while it's essentially offline but users are still running, and then rebalance your load again, all without disrupting users. That's powerful stuff if you need to avoid downtime. The last category of benefits of virtualization is operational flexibility that this can give your business, and it's all about competitive advantage. If you can run your IT cheaper, keep your applications available for users more often, and do IT in a better way than your competitors, then you do have a competitive advantage over them. You can, as an example, do this through faster server and desktop provisioning. You no longer need to order and wait for a physical server to be delivered to you, which might take a week or 2 or 3. But instead, if you have the extra resource available because you're sharing, you simply, in 5 minutes or so, create a new virtual machine, and then, which is like receiving your physical machine in the mail, but only takes 5 minutes, and then install your operating system, which often goes faster as well. But there are some drawbacks to virtualization, so I want to be fair and speak about some of those. The first is that we are talking about concepts of virtualization. They're obviously new. They may be a little bit more complex than the environment that you have now because you're introducing a new layer of software with its own terminology, way of managing it, honestly. The implementation is not terribly tough, but there are a new set of management tools that you need to be aware of if you do virtualization, because you need to use these tools to monitor and create virtual machines. And you haven't had them before, but you'd have them now, so you just need to be aware of those. There's often additional products and support costs associated with this. Although some virtual software is free from the manufacturers, often you want to pay for a version that is supported so you can call for tech support or get free upgrades. So I'll speak about the costs specifically in just a couple of slides. And another drawback of virtualization is that special requirements your environment may have may not be supported. And a good example would be, say, analog modems that you do faxing out of don't work terribly well on a virtual server just because of the way that things run and with serial ports. Or maybe you have some specialized graphics hardware in your desktop that augments your CAD/CAM functionality or scanning of documents. Some of these things can work, some may not work as well, so we'd want to help you through that process of identifying if there are any special requirements that your environment has where we wouldn't necessarily want to do virtualization. Let's get right into some resources, some products that can do server and desktop virtualization. Here's a list of the major vendors like VMware, Microsoft, etc., and the names of their products that do virtualization underneath. I put an asterisk next to the first one. It's from VMware Company. It's a product called Vsphere 4, used to be called ESX, if you've heard anyone say that. That is the product that the network support company primarily or leads with when we speak to new clients interested in virtualization, both for server and for desktop virtualization. That's because we found VMware's product to be the most mature and feature-rich product itself, and has a set of products in the family that surround it and really make it quite capable if clients might need that. They are the dominant market leader by far, even though the other players do virtualization well. No one has the market share like VMware has, so we feel confident in their level of ability to develop good products, support them, and have the installed base to flush out any issues. They also provide world-class support that's either direct from VMware or through HP, which is a strong reseller, an integrator of VMware into their products. So often HP servers can come preloaded with VMware software. Well, if you're getting at this point perhaps interested in considering virtual systems in your environment, you might want to know what the requirements are. So let's jump into that. If you want to run virtual servers on a single physical server that they all share, two basic things that you need. We need to ensure that the physical server that you have is on the compatibility list of that virtual server. Vsphere has something called the Vsphere hardware compatibility list, and it's simply that they've certified that the hardware that they have tested can run the Vsphere software without issues. You wouldn't necessarily get Joe Schmo white box PC out of the back of his garage and he says it's a server and try to put Vsphere virtualization software on it. You'd want to make sure that it's on the list because it may not run or it may run poorly if it's not. Now, nearly every server from HP, Dell, IBM are on the hardware compatibility list, so it's not a terribly short list. It's huge, but we do want to make sure that the equipment that you have is there. And then secondly, you actually need a Vsphere license. The latest version is 4.1, which came out a month ago, and it just shows that they have a lot of history building this. They've been doing virtualization for, I think it's 12 years or more. Sometimes those licenses are free. It's an unsupported version. The free version is limited to 2 core CPUs, but if you purchase software from them, which I'll get into the exact cost in just a sec, then it removes those limitations or adds new features. But let's speak about the deployment method first. If you want to deploy a virtual server, what would it take? Well, we install the virtual server software like Vsphere from a DVD. You just boot up the server. It does the install, which takes about 20 minutes. We provide some simple information like what is that virtual server's host name and unique IP address, what time zone you're in, put in the license information. Again, just another 10 minutes or so. Then we're ready to create our first virtual machine, which is kind of like that container that holds Windows and then all of the operating systems. And this is what you do instead of purchasing a server and waiting for it to come in the mail. This is what takes 5 minutes to create a virtual machine. Then you install your operating system and your applications, and that time is roughly the same as what you take to do a physical server. Can be a little quicker through some ways that we have of copying that operating system CD onto the virtual server and using it there instead. It runs faster. And virtual desktops are deployed very similarly. First step is installing that virtual server software like I just described in the prior screen, so it takes about the same amount of time. Then we install that special desktop management software that I spoke of that helps to manage virtual desktops specifically. That can take about a half an hour to an hour. Then we create virtual desktops. Similar, you create a virtual machine, then you install your operating system and applications in it. Once you do that once, you can make a master copy of it so that the process of creating the second, third, fourth machines, as an example from this master copy, only take about 5 to 10 minutes, and it's all done automatically for you. Once you install the operating system and applications, you install some additional software that allows it to be connected to. It's a technical thing, but it is required. Assign some users to which desktops they can get to, and then configure their end user devices to connect to the virtual desktops, either via thin clients or the View client software, which can be put onto PCs to make them really like the thin clients I spoke of. So let's get into more on the cost. I spoke how with server hardware, you're generally spending, on average, this is across the industry, 1/10 of your previous server hardware costs because you're taking greater advantage of the server that you are buying, so you don't need to buy something that's 10 times as powerful as each one of those. You then need to buy the Vsphere license, and I'll bring up a slide next which talks about the exact costs. If you're doing virtual desktops as well, that's an additional, on average, $180 per PC to virtualize it. And then, although it's not required, having a support and subscription contract from VMware, which gives you the ability to call for tech support and get upgrades, that's the subscription part of it, is optional but is recommended. Those might be additional costs. Now, in terms of free, I spoke about the free version of VMware that can be used on a limited basis, or the network support company can demo these technologies in our headquarters in Danbury if you like. And currently, VMware is providing to clients directly a free 60-day trial. So if you provide the hardware and you ask the network support company to assist you with the labor, VMware gives you the free licenses to run any product that they have for 60 days. It can be in a production environment. You try it. If you don't like it, well, we rip it all out. If you do like it, you just pay for the licenses of the technologies that you used, and you continue to use it like you did in the 60-day trial. Specifically, vSphere comes in many different editions. You see the yellow Essentials boxes and then the blue Standard Advanced Enterprise. Most clients with a single server environment that want to run multiple virtual servers on that one physical box would buy the Standard Edition, and that is just about $800. They price it per CPU. So that means if you have a server with a single quad or 6-core processor in it, you pay $795. It doesn't matter how many cores are in that processor, it's by processor. So 2 quad cores, you would pay for 2 CPU licenses, or what's that, $1,600 or so. If you want advanced functionality, meaning 2 servers that provide redundancy and load balancing for each other, so you don't have a single point of failure, then the price per CPU for every CPU, both in the primary and that backup box, is higher, and that would be the Advanced Edition for $2245 list price anyways. So I want to start bringing this in for a landing because I want to be sensitive to time as well and leave question and answer. Is that really all of this is trying to address this particular problem. And if we look at this graph, on average, IT spends, looks like 42% to maintain infrastructure, like servers and network, 30% to maintain applications, but only really invests in new applications and new infrastructure, what's that, 28%, let's call it a quarter of the time. So most of your money is going to keeping things running the way that they are, whether it's good or it's bad, and not much money is going towards improving the way that you do business, making applications really work for you, providing the data to the end users that you want. So virtualization technologies hopefully take some of the money that you spend on maintaining what you currently have, like your servers, frees it up so that you can invest instead in what actually benefits your business more than the way that you're doing IT today. Well, that is just about it. So I thank you for listening to me ramble on. Sorry that it couldn't be more interactive, but I would like to get to the point where you guys can ask some questions and we can use our remaining time for that.
Okay, so if there are any, I have a few questions here, but if there are any additional questions, please go ahead, excuse me, and ask your questions via the question box that's sitting on your console in front of you. The first question that I do have today, Kevin, is, will my current hardware and software work for a virtual trial?
So that would be, I guess, that 60-day trial period. And if you have some hardware laying around, well, we have to remember that we have to check out that hardware to make sure it's on the hardware compatibility list, which often it is unless it's ancient or not really server class stuff. That's on VMware's website, or your tech from the network support company can assist you in making sure that it all is on that list. The second thing that we would want to make sure is that the virtual desktop and the client hardware is ready to do virtual desktops. So if you're going to reuse a PC that you have now and do virtual desktops specifically, there is one caveat with the physical PC that you might leave at the desk in order to continue to be used as a thin client, and that's something called a CPU ESS feature. Almost all PCs these days have it. Some ancient desktops don't. So we just want to make sure you don't intend to use a PC as a thin client and then not be able to. But it is best to do a 60-day trial to flush out whether there are any special hardware or application requirements before you actually start investing in the licenses.
Okay, and we have a follow-on question to that. We have 2 servers that are out of warranty, and we are looking at replacing them. Are you saying that we might not need to replace these servers, but could use them if we are using virtualization?
Yeah, so I think that the suggestion there was if you have 2 servers and you're not confident that both of them are very reliable, could you use the redundancy feature that I spoke about with virtual software so that they are kind of like backups for each other? So here's what's involved. Again, making sure that those servers can run the virtual software, buy the advanced edition licenses, which allows you to do the redundancy, and then we have to have a shared storage array in between those 2 servers, which doesn't have to be a lot of money, but they do need to share hard drives in between them, and we put the virtual machines there. That's what gives it the magic of if server number 1, because it's older or less reliable, fails, the other one can still get to the same virtual machines and keep them running. So I hope that answered the question. I think basically the answer is yes, you can extend the life of server hardware and use virtualization software to do that.
Okay, we've been, the next question. How much time is required to implement virtual servers and desktops?
Mm-hmm. It usually takes just about an hour total to install and configure that vSphere virtual server software. Then it takes about 5 minutes for each virtual machine, which is that container to install Windows into, which isn't very much at all. And then you would do whatever normal time it takes to install the application and operating systems, unless you're using the features to copy an existing server to clone it and just change its identity in the way that you need. Is there another question as well?
Yeah, we do have another one. It's similar, but it's more geared towards support and the effort required. How much effort is required to support virtual servers and desktops?
Mm-hmm. Good question. So not so much the time to implement it, but the time to support it.
Right.
Well, virtual machines really don't take much more time to support because really Windows is Windows. So just because your Windows Server or Windows Desktop is virtualized doesn't necessarily change how you manage it. There might be some other technologies that you use to manage Windows better, but because it's virtualized, it stays about the same when you're virtualized. But some tasks do take less time, and that's regarding like cloning a server or a desktop to make a copy of it so that you can easily roll it back after, say, a bad change. The virtual software also does perform centralized patching of Windows operating systems, just like WSUS or Windows Update can, so you can save a lot of time supporting your virtual desktops and servers in that way. There's also some additional tools that you get when you virtualize servers and desktops that allow you to remote control a virtual console of that virtualized PC or desktop. Forgive me for using the word virtual a lot here. It allows you to take over the console even if that operating system won't boot. So yes, we have our remote control technologies like VNC and remote desktop that can take over a machine when it's running well, but if it's virtual, you can take it over even when it's not booting or running correctly. And that's really kind of neat. You can also review the historical performance of your virtual servers and desktops using additional tools that only come with VMware to ensure that users are getting the best response time possible. Usually when a user has a PC at their desk, we really don't look at it and monitor its performance except when there's issues. But now that they're all centralized, we can keep an eye on them better.
Okay, we have a couple more. Our users are supposed to work off the network server and store everything there, but individual users do have information on their C drives. In converting all computers to virtual machines, how do you save that individual C drive information?
Okay, I think I understand that. So if you virtualize all your desktops, but users had custom information files or settings on their individual PC, how do you preserve that for them?
Right.
Well, one way would be that when you virtualize that PC for user John, we would configure it such that when John connects to the virtual desktop farm, he would always connect to the PC that is a replica of what he had on his desk. So now that it's been virtualized, it's now running on the back-end server, but still has the same operating system, applications, settings, and files that he had on his physical PC. They just happen to be all moved en masse to that back-end server. And through security, we can set it so that no other user can connect to the virtual desktop farm and connect to John's now virtual PC. Did that sound like it answered the question?
Yeah, it does. Our last question is, how does virtualizing servers and desktops change Microsoft licensing compliance?
A fine question. Generally speaking, it doesn't change the rules too much in that each Microsoft product still must be properly licensed. So as an example, if you have virtualized John's PC that had Microsoft Office 2007 on it, just because it's running as a virtual machine on your server in the back room, he still needs a Windows operating system license and the license for Microsoft Office. Where it runs doesn't make a difference, but because he's running it and he's accessing it, he needs a license. A couple times the licensing rules does change, and this is more regarding terminal services, which is a way of sharing a Windows server and giving people desktops, but not really their own desktop operating system desktop. And then the rules change to be whoever accesses it must have a license for that application. So even though 5 people may only be in the virtual terminal server at one time, if there are 20 people over the course of time that do access it, you still need 20 licenses, not the 5 that are in use at that time.
Okay. In the previous response, you mentioned security. This next question is regarding security. Is virtualization less secure than on-site servers?
I'm just thinking about that response so I don't give a glib one. But I can think of no way that virtual servers are less secure, and for a few reasons. Let's take it at the Windows virtual server level. So if you've got all your Windows operating system and it had its security either through file system permissions or encrypting the file system, all of those features still stay in play when they're running virtualized on that box. In fact, things might be a little bit more secure because not only do you have Windows handling some security, but you also have the VMware software adding a couple different features for security. So if those hard drives ever got stolen out of the server, as an example, it'd be very tough, very, very tough for someone to get through the VMware layers of technology and figure it all out, and then look inside the virtual machine files that are there and get through the Windows layers of security as well.
Okay. All right, that wraps up our questions for today. If there are any additional questions, you can always reach Kevin. Oh, wait a minute, I do have one more. Explain cloud computing. Is this what virtualization is? Oh, see, our last webinar was on cloud computing.
Yeah. Yeah, cloud computing, I understand that there's a lot of confusion because unfortunately
Right.
there's a lot of definitions of what is it, what isn't, and people's understanding is quite varied. Cloud computing is doing virtualization usually like this, but it's not done at your site in your data center. Cloud computing is providing virtual servers and desktops and other resources across the internet somewhere. So someone else manages the virtual servers and the hardware and the disk arrays and the licenses, etc., and just allows you to access it over the internet. That's cloud computing. You can do the same sort of technologies that they take advantage of to save money and provide it cost effectively at your site if you so choose, and that is sometimes called private cloud computing. But usually we don't say that. Usually we just say that you run virtual servers or virtual desktops.
And there is a question regarding, does the network support company offer cloud computing?
Yes, we do. We call it something different. We don't call it cloud computing, but we've been doing it now for 3 years or so. And it's a service offering called Host IT. And it means that we host your information technology, Host IT. We host your servers virtually in our data center in Florida. And we run the same technologies as what I've been speaking about today. So again, it's just showing how cloud providers run virtual server, and you can either do it at your site and keep it private, or you can let the network support company do it for you.
Okay. There are a couple of additional questions, and what I'm going to do is, Kevin, I'm going to ask you to give out your email address, and perhaps then what we can do is get a few follow-up questions answered via Kevin's, Kevin directly, or somebody else at TNSC. So
No
Kevin,
problem at all.
That'd be great.
Yeah. My email address is K like Kevin, Rhodes like my last name, R-H-O-D-E-S, K Rhodes at network-support.com. And I'll take email questions on these sort of topics and either answer them myself or refer them to an appropriate party in the network support company for you. If I usually get those back in a day or two if I can. And I'm also willing to stay, Linda, on the phone until 12 or even a little after, 11, if we want to handle a few more like that.
Okay. Okay. Let me do this. I'm going to do one. There are 2 other questions. I'm going to throw one thing quickly out there, and then I'm going to ask these other 2 questions. Our next event is September 16th, and it is in Danbury. It's a seminar on disaster recovery. So please look for that invitation to be coming to you in the next few weeks. If you are interested in this before, and you want to get some details before, please send an email to K Petroff, and that email address is KPETROFF@network-support.com. So let me get these next 2 questions in. Is cloud computing more cost-effective than virtualization?
Well, I'll take that question as being, is cloud computing more cost-effective than doing private server and desktop virtualization, doing it yourself? Because, again, really the same technologies that are used, it's just used by other companies across the internet versus you doing it yourself. I would have to say, generally speaking, it can be cheaper in one respect. If you do it yourself, you're usually spending more on the capital side up front to purchase the server hardware, the licenses, maybe some training for yourself. Whereas if you do cloud computing, it's usually strictly you pay this much per month, and that's usually considered operating expense and is very flat over time. So one way to choose whether you do it in-house or have someone else do virtualization for you through cloud computing is to find out from your organization whether you are capital risk averse or operating averse, and float it either way. Overall, when capital and operating aside, does it make more sense? Often cloud computing companies can do it cheaper, they buy in bulk. They're hosting many more hundreds of servers than what you would ever have in your environment. So they have those economies of scale, but you do have to remember that they're also trying to make some profit on that so you can do it cheaper without profit in-house. So no bottom line answer, except that I'd be happy to help you, do some particular investigation of, okay, what are you looking at in your environment? Let's cost that out. And then we have a couple particular partners in cloud computing that we use, either ourselves or others that do virtual desktop as well. And we can price out those alternatives for you and see how the two compare.
Okay, and then this next question is in regards to our Florida facility. How is speed with your host IT offering in Florida?
How is it? So response time and such. I'm sorry, was there more to that, Linda?
Yeah, it sounds like it was more to response time and if they're tagging in through Florida, what's the response?
Oh, okay. One neat thing about virtualization of servers and particularly desktops is that it doesn't make so much difference how far the user is then from the virtual desktop, whether it's just across a local switch in your environment to your own computer room or across the internet to either the network support company's environment or some other provider. Because all the computing is still done in one place, and that happens just as fast no matter where it is, and then just the display of what is happening is sent across, which is very low bandwidth, so it gets there pretty quick. Now, I would never think that a remote provider like the network support company or some other cloud computing host could provide you, the exact response time that you get locally, especially if you have really fast servers, really fast network, and they're only 10 feet away. But it is generally pretty good. Performance-wise, in terms of calculating versus processing, which I just spoke about, you're talking about companies that generally run big, powerful servers like the network support company does, and the response time for computing is going to be pretty good.
Okay, last question is regarding disaster recovery. Does virtualization prevent crashes?
No, but there are some techniques and some features that help when those sort of things happen. So crashes can either be one of two types. They can either be something went wrong in the software, the application, or the operating system, or it can be in hardware. I had a piece of hardware fail. So it doesn't prevent those things from happening, but it can assist when they do happen, and some cases prevent your users from actually noticing. So let me speak about each of those individually. If something goes wrong with the operating system and it blue screens, Windows has the blue screen of death, virtual server software from VMware can either restart that operating system on another server automatically, so it notices that the server went away and says, oop, that's a problem. 5 seconds have gone by and I haven't heard from that Windows server. It must be down or crashed. And it immediately starts up another copy, so Windows boots on the other server, and all your applications come up. So that maybe takes 5 to 10 minutes to recover. The other way is if you have a hardware failure, how does it protect you in that? Same sort of thing. If one physical server fails and all those virtual servers and desktops fail then because of a result of that, again, high availability feature it's called, would notice that all those things have gone away and start them not up on the same server, but start them on the other physical server that you have remaining. And again, that takes 5, 10, 15, 20 minutes to start all those things, depending upon the load and the speed. But the last really neat feature how to protect against hardware failure is called fault tolerance. So you run 2 physical servers running virtual software. They share the disk array that runs everything in between them. And you actually run that virtual machine, call it your Windows Server number 3. It's actually running on both servers simultaneously. They're communicating and keeping each other up to date. Now, to the users, it only looks like there's one server. But technically, there's actually 2 copies of the operating system and apps completely in sync running on each individual physical server. if one of those physical servers fails that was running one of those copies, VMware immediately notices it and just keeps on running without missing a beat, keeps on running the other copy, and it responds to users. So there's no boot time, no failover time. Users don't notice that one copy has failed because it's all kind of like mirroring in the background. And that's how it protects against failures. Although it doesn't prevent them, it can help with failures.
So having what just came in to follow up, so having virtualization makes disaster recovery almost seamless. You wouldn't need days to recover new hardware and additional time to load software, et cetera. That sounds like they're just trying, we're trying to get confirmation there.
Yes, that is correct. That it definitely lends itself towards certain types of disaster recovery. Now, there's many levels of disaster recovery. Having tape backups of a single physical server so that you could restore from backup tapes is disaster recovery. It's not a great way because it takes a long time to do. You have to acquire the hardware, etc. But if you do virtualization and the fault tolerance or the high availability, which I just spoke about, you get in the computer room protection against single points of failure of your server hardware. You can, in some cases, extend that so you're copying your data from one data center to another remote data center so you can get data center level disaster recovery. It takes a bit more work, but that can also be done. So yes, definitely lends towards helping with DR.
Okay. We've got all our questions answered, and it was very interactive today. I'm glad you guys were able to ask the questions that you were able to ask. And we'd like to thank you once again for joining us. It went a little bit longer, but it sounds like there was we were able to answer some of your questions. And again, if you have any additional questions, please call your Network Support Company account manager at 203-744-2274. Kevin also gave out his email. And we thank you and hope to see you on future broadcasts.
Thank you, everyone. I enjoyed it.
Bye-bye.